Today, we'll explore one of the most exciting challenges in machine learning, teaching a computer to tell the difference between cats and dogs. By the end of this video, you'll understand how classification algorithms like decision trees work, how to measure their accuracy, and how to spot their mistakes using tools like confusion matrices. No coding experience? No problem. Let's simplify this step by step. Let's start by imagining you resorting photos into two folders: cats and dogs. Your brain effortlessly recognizes features like floppy ears, whisker length, or tail shapes to decide where each photo belongs. Classification algorithms replicate this process. They learn patterns from labeled data, like photos already tagged as cat or dog, to predict labels for new, unseen data. But how do machines learn these patterns? Let's talk about decision trees, a visual and intuitive algorithm that mimics how humans make yes-no decisions. Think of a decision tree as a flowchart. Each node asks a question about a feature of the data, and each branch represents a possible answer. For example, the first question might be, are the ears pointy? If the answer is yes, the algorithm moves to the next question. If no, it might classify the animal as a dog, assuming floppy ears are a dog trait. The next question could be, does the animal meow? A yes leads to classifying it as a cat. A no confirms it's a dog. The goal is to split the data into groups that are as pure as possible, meaning all cats end up in one group and all dogs in another. The algorithm prioritizes features that best separate the data at each step, like choosing ear shape over whisker length if it improves accuracy. Once our decision tree is built, we need to test its performance. This is where training accuracy comes in. It measures how well the tree classifies the data it was trained on. For example, if 95 out of 100 labeled cat-dog photos are correctly sorted, the training accuracy is 95%. But here's the catch: high training accuracy can be misleading. Imagine a student who memorizes answers to practice tests but fails the final exam. Similarly, a decision tree might overfit the training data, learning quirks like all photos taken at night are dogs, which want to work for new data. That is why we always test the model on a separate validation dataset to ensure it performs well in the real world. Even the best models make mistakes, and that's okay. To understand where the errors happen, we use a confusion matrix. Let's say we classify 100 animals. The confusion matrix might look like this. 45 cats were correctly identified as cats, but 5 cats were mistakenly labeled as dogs. Meanwhile, 40 dogs were correctly classified, but 10 dogs were mislabeled as cats. From this, we calculate two key metrics: precision and recall. Precision answers the question, how many of our cat predictions were correct? In this case, it's 45 correct cats divided by the total predicted cats, 45 plus 10 mislabeled dogs, 82%. Recall tells us, how many actual cats did we find? Here, it's 45 correct cats divided by all real cats, 45 plus 5 missed cats, that's 90%. High precision means fewer false alarms, e.g. fewer dogs called cats, while high recall means fewer missed cats. Depending on the goal, like finding every cat in a shelter versus minimizing mislabeled dog photos, you might prioritize one metric over the other. Let's recap what we've learned. Decision trees use simple, feature-based questions to classify data. Training accuracy helps evaluate performance on known data, but beware of overfitting. And confusion matrices reveal error patterns to fine-tune your model. These principles aren't just for cats and dogs. They're used in medical diagnoses, spam detection, and even predicting customer behavior. The core idea remains the same. Machines learn from patterns, and we measure their success to improve them. Thanks for joining this journey into classification algorithms. If you enjoyed learning how AI distinguishes cats from dogs, imagine what else it can do. Subscribe to AI Simplified for more bite-sized lessons that turn complex topics into aha moments. Hit the bell icon so you never miss an update. and let us know in the comments, are you Team Cat or Team Dog? See you next time.